Hello students, my name is Ankit Mittal. How are you? Today in this video, I'll take you through an important property of conic section. That is, the harmonic mean of the segments of a focal chord in any conic section is equal to its semi-latus rectum. This property is true for any of the conic section, either it be ellipse or parabola or hyperbola. To prove this property, we will use a plain geometrical method, will not use any parametrical forms or any coordinate geometry. There are several proofs to this property using parametrical forms or coordinate geometry, but those proofs are specific to parabola, ellipse or hyperbola. This is a general proof. It uses the basic definition of a conic section and plane geometry that we have already covered in class 10th. So first thing, what is harmonic mean? For those students who are not aware of what is harmonic mean, for two positive numbers a and b, harmonic mean is simply defined as 2 upon 1 by a plus 1 by b. This expression can also be written as 2 upon harmonic mean is equal to 1 by a plus 1 by b. This means harmonic mean is simply a real number obtained from the two real numbers a and b. Second question is, what is a latus rectum? Let us come back to our question and then we'll discuss what is a latus rectum. I am considering a lot of you students would already be knowing what is a latus rectum. Let us consider this as a conic, this curve as a conic. It can be part of a parabola or an ellipse or a hyperbola. Let this NK line be the axis of this conic. This line TT dash be the directrix of this conic. And this point S be the focus of this conic. Now we'll discuss what is a latus rectum. We know in a conic section, latus rectum is defined as a chord that is parallel to the directrix and passing through the focus. So in this case, the chord UU dash becomes my directrix. Latus rectum. Now since NK is the axis, this means the portion US is the semi-latus rectum because axis will divide UU dash in half. Now I draw a focal chord. The chord PR passes through S, the focus of the conic. So I can call it a focal chord. Now if I rephrase my question, I can say I have to prove upon semi-latus rectum US must be equal to 1 upon PS plus 1 upon SR. Right? The harmonic mean should be US of which two numbers? PS and SR. So let's start with our proof. Initially, we'll consider two triangles PSK and RSM. We can see the angles MSR and PSK are equally because they are vertically opposite. The angles RMS and PKS are equal because they both are 90 degree each. Hence I can say by AA, these two triangles are similar to each other. Now using the condition of similarity, I can say the ratio PS upon SR, PS is the line segment opposite to 90 degree in this triangle, SR is opposite to 90 degree in this triangle, must be equal to SK over SM. SK is opposite to this angle and SM is opposite to this angle. Now I'll use this expression and manipulate this to obtain our result. I can write SK as NK minus NS, and I can write SM as NS minus NM. This is how it looks like. Now I multiply and divide this expression by E. E is the eccentricity of this conic. It can be 1, it can be greater than 1, it can be less than 1. Depending on what sort of a curve it is, parabola, ellipse or hyperbola. So it is a conic with eccentricity E. Now coming back to our figure, I can see the length NK is same as PT dash. The length PT dash. So I replace NK by PT dash. Second, I can see the length NS is same as QU, because this is a rectangle 90 degrees. So I replace NS by QU. Over here also I replace NS by QU. Similarly, I replace NM, this length, by TR. Why am I doing this? I'll just explain to you in a moment. I know the basic definition of a conic section. It says if there is any point on a conic section, let us say P, then the ratio PS over PT dash, that is the distance of the point P from focus to the distance of the point P from the directrix, must be equal to the eccentricity of the conic. If it is ellipse, then this E is less than 1. If this is hyperbola, this E is greater than 1. And if it is a parabola, this E is equal to 1. Now, since I know this property, and this is true for any point on the conic, I'll use this property. I can see E times PT dash. E times PT dash can be written as PS. So I write E times PT dash as PS. Similarly, if I consider a point U, the distance US upon the distance UQ must be E. So I can also write E times QU as equal to US or SU. I'll replace this E times QU by SU, and also similarly for the point R. If I see the point R, I can also write E is equal to the distance of R from S divided by the distance of R from the directrix. So I replace E times TR by SR. So essentially what I have now is PS upon SR is equal to PS minus SU upon SU minus SR. This is the expression that I have got. I cross multiply this expression. I get PS minus SU upon PS is equal to SU minus SR upon SR. If I rearrange it, what will I get? PS by PS is 1 minus SU over PS is equal to SU over SR minus 1. This gives me a result 2 is equal to SU over PS plus SU over SR. If I cross multiply SU, I can also write this expression as 2 over SU is equal to 1 over PS plus 1 over SR. And this is precisely the expression that we had to prove. Now remember, this is a beautiful proof using simple geometry. It does not use any property specific to parabola or ellipse or hyperbola. It is a property of general conic. It is true for all the three conics, parabola, ellipse and hyperbola, and it is an important property. So the application of this property can be in questions where you are given the length of two segments of a focal chord and you are asked the latus rectum. So if the two segments are given, say 3 and 4, you can easily calculate the length of latus rectum from this formula. So this is one property that I have discussed. I hope you enjoy this and you learn this method. Thank you for watching.